Hi, welcome back. In this video, we're continuing to talk about operations on functions. In the last video, we defined the operations addition, subtraction, multiplication, and division. And in this video, we're going to look at whether these properties are commutative. I have a video on the properties of real numbers, but as a reminder, the commutative property means, can these be reversed and have the same thing? So another way of saying this is f plus g of x equal to g plus f of x. Is f minus g of x equal to g minus f of x? Is f times g of x equal to g times f of x? Is f over g of x equal to g over f of x? I'd like you to pause the video now and think about these. Maybe do the math out on your own and come up with what your thoughts are on whether or not each of these properties are commutative. So pause the video now and do that. Okay, so I hope that you gave some thought to whether or not these properties are commutative. We're actually going to go through the math. I'm going to go through it a little bit quicker than we did in the last video to see whether or not f plus g is equal to g plus f, and so on for each of these. So g plus f of x is going to be g of x plus f of x. So g of x is 2x plus 1 plus f of x, which is x squared minus 4, giving me x squared plus 2x minus 3. Giving me two equal statements. So yes, these are commutative. And if we think about what we're doing, this makes sense. I'm taking the same value of x and inputting it into each function, and I'm getting an output and then adding those outputs together. So addition of real numbers is commutative, so it would make sense that the addition of two functions would also be commutative. So now let's look at subtraction. So if I'm looking at g minus f of x, this is g of x minus f of x, which is 2x plus 1 minus x squared minus 4. Don't forget to distribute that in. And what we end up getting is negative x squared plus 2x plus 5. And what we can see here is that these are not equal. So subtraction is not commutative, which makes sense because subtraction of real numbers is also not commutative. Looking at multiplication, is this true? So let's look at g times f of x, which is g of x times f of x, or 2x plus 1 times x squared minus 4. Don't forget to distribute, and you end up getting 2x cubed plus x squared minus 8x minus 4. So what you see here is these are equal. So yes, multiplication is commutative. And looking at whether f over g of x times g over f of x is commutative, looking at g over f of x, this is g of x over f of x, which is 2x plus 1 over x squared minus 4. These are not equal, so division is not commutative. Again, multiplication and division following the same rules as whether as addition, subtraction, multiplication, and division of real numbers.